Very good evening to all of you. Welcome all the staff members of Government Engineering College and the Polytechnic for this AROHAN series 20. And it has been the platform for all the staff members to share their ideas among themselves, as well as we have got an opportunity to invite experts from reputed institutions. Today we have eminent speaker, Dr. Monica M. She'll be delivering a talk on professional email etiquettes, time management. She's an MBA. She's from MBA department. To introduce briefly, Dr. Monica is a management professional and assistant professor with 13 years of experience in education and management, and also the assessment, training, and placement coordinator at Acharya Institute of Technology, and has a doctorate in business administration from Visvesvaraya Technological University, Belagavi. With a strong background in academia, she has 20 publications in esteemed journals and has been honored with 3 Best Paper Awards. Actively involved in faculty development programs, workshops, conferences, and MOOCs, massive open online courses. Dr. Monica demonstrates a proactive approach to a professional development. Her exceptional organizational skills shine through her successful coordination of international conferences and student development initiatives, highlighting her expertise in teaching, research, and academic leadership. So, thank you very much, Monica, for accepting our invitation and really accepted our invitation and agreed to share your ideas with our faculty members. Now, I request you to please take over the floor and continue your presentation. Thank you.
Thank you, sir. I'm just uploading the PPT.
Yeah, we can share the PPT.
Oh, PPT is visible?
Yeah. Make it full screen. Make it full screen. I have shared full screen.
Is it visible?
It is not in presentation mode.
Madam, share entire screen now. Just stop presenting. The third tab you have entire screen.
Yes.
After window. Just click on that screen and then share.
Done, ma'am.
Now move to PPT, ma'am. Slideshow. Yes, ma'am.
Okay.
Now we are getting.
Yes,
A warm good evening to all the professors. Myself, Dr. Monica. As sir introduced me, I'm a assistant professor as well as a assessment training placement coordinator at Acharya Institute of Technology. Before I start with my talk, let me take this opportunity to thank Dr. T.G. Basavaraj sir for interesting me and giving this opportunity to present or talk on professional email etiquettes and time management. All of us are, there are 2 key terms that defines our professionalism at workplace: our emails, the way we are going to effectively draft the email, and how we are going to manage the time. So these are 2 key aspects that I'll be talking about for today's session. All of us as a professors or teachers, we know that how to craft an email and what are the various elements are there in the email. If you see this particular window, we'll be able to see that the entire email view. We know that there are various elements of emails as well. But what are the do's and don'ts when we are crafting email and sending an email to the recipient? So today, I'm going to explain about what are the do's and don'ts, what are the professional etiquettes which are required for email writing. effective email writing. Moving on to, as I told, I'm going to talk about the important elements of email etiquettes. So if you see here in this particular window, there are various elements, that is to, from, CC, BCC, subject, and body of the email. So along with that, there is an attachment which we can able to do it. Here, most of us face a challenges when we are crafting an email, what subject line to be written. So that's the first and foremost, we have to identify a simple, concise statement that defines the purpose of writing an email. So if you can able to, if you're writing an email requesting for a leave, so you have to put that in a subject line, which is concise and simple. So here I put one example. If you see this particular email where all the content, what's supposed to be written in the email, body of the email has been written in the subject line. So this clearly indicates, and people would start judging that our incompetence or incapability in terms of crafting an email. So this has to be completely avoided. So when we are writing an email, we have to make it very simple subject line that summarizes the main purpose of writing an email. So moving on to, we have a second element of an email, that is professional salutation, which we say greetings. So the way we are going to write in letter, or when we meet someone, we are going to greet. So similarly, we are going to, when we are writing an email, we are going to put a greetings. That is called as a professional salutation. So here, hey, hi, these are the terms which have been, most of them are going to use. Though we are going to have a very friendly relationship with the recipient, that is not allowed in a professional setting. So we have to write dear doctor, dear sir. If at all, if you're writing hello, you have to add Mr. with the name. So that is the allowed one, which has to be known based on the relationship which we are going to have with the recipient. That's an element which we are going to have. Then we are going to have an email text body. So when we are writing an email, we think that people would like when we are putting a lot of content in the email. So which has to be completely avoided. Or sometimes we receive an email which is not organized properly, there is no logical sequence. So you have to make sure that when you're writing an email, there is a structure, proper structure, which can be added with the bullet points and properly start with the email, and you're going to end an email. So when you're ending, you're going to put a sign off. So sign off, that is a closing statement we are going to give. Like the way we are going to add best regards, thanking you sincerely. So these are the words which can be added to sign off or to end the email. And the most important one, which we can able to add in to create a professional email etiquette, that is adding a professional signature. So what is this professional signature? So your name, title, contact number, contact information that can be presented. So if you see this particular email, the moment we add this professional signature, when you craft an email, automatically the signatures get added. So it looks very professional, which talks about your name, designation, your qualification, institute name or college name or company name. So all the details can be added. So this is the signature which you can add in. So here we have this general settings. You can add in the signature. You can have multiple signature added here. You can create your professional one, or in terms of informal one, you can have 2 or 3 professional signature that can be added. Why we say 2 or 3 professional signatures that can be added is sometimes we don't want to share a contact number. So you can have another professional signature that is added without a contact number. So that is about another element what we have in terms of email etiquettes. So subject line, which has to be simple and concise, start with a professional salutation, use respectful and appropriate greetings when you are mentioning in the email. In the email body text, make sure that you don't add too much of information, colorful with a lot of information there. Sometimes we make it very illogical. So make sure that the entire email text body, what we are going to have, is very structured and concise. So add in appropriate closing in terms of thanking you, warm regards, best regards, so sincerely. So all this then can be added. So along with this, please include a professional signature that is very much required when you're sending an email. Here, why have we included this attachment as one of the element of email is, most of us, when we're attaching an email, attaching a document in an email, we tend to attach a wrong file or the file name is not appropriate. So in the professional setting, when we talk about sending an email to an employer or requesting for or contacting the customers, clients, so we have to ensure that the file name is appropriate before sending it, verified whether it is a correct file or not. So we say draft 1, draft 2, and keep saving the file. So when we are attaching a file, we get confused whether the email is, attachment is right or wrong. So you have to ensure that the right attachment, a proper one, labeling has to be done properly. So we have, when we are sending an email, there are 3 fields which we are going to address to 2CC and BCC, which all of us know about it. So 2 is the one which calls for an action. So if you're drafting an email to requesting for a leave, it has to be in 2. So if somebody has to be kept in loop or somebody has to receive that information about your leave request, those in email IDs has to come in carbon copy. We have another element that is blind carbon copy. This is very much useful when we have to keep the information private, or when we are sending this email to the large number of people. So here, if I'm sending an email to the 100 customers, I have to put all those 100 email IDs in the BCC, blind carbon copy. So these are 3 fields what we have in terms of 2CC and BCC. Then we have an option to reply and reply all when we receive an email. So when we say reply, we have to ensure whether to go for reply or reply to all. In case if there is no scenario where we have to click on only reply, and in case if you go for reply to all, then it creates a lot of misunderstanding and conflicts might arise. Or if you have to reply to all, keeping them informed, instead of that, if you reply, that creates a communication gap. So in order to avoid this, make sure that you use this reply to all very carefully. So this is the format of an email, what we are going to have. You have 2CC, BCC, and a subject line. So here we are going to start with a salutation. You can see there, it is mentioned, hey there. That is a salutation. So which is not at all acceptable in a formal setting, because we are not supposed to use hey, hi when we are addressing or sending our information to the recipient. So you have to make sure you're going to say good morning or good afternoon, good evening, or you're going to say warm greetings, or you can say dear doctor or dear Mr., dear professor. So that can be mentioned as a salutation. Then comes the email body, as I mentioned. It has to be very clear without confusing. Here, most of us, what we do, we wanted to highlight and make it in red or add colors, or we wanted to make it bold, increase the font size, style. So we wanted to make it very colorful, which is not acceptable in a professional settings. Then you're going to have this closing statement, signing off, thanks, warm regards, that can be added there. So then comes your signature. You can add a logo if you want. You can add a company name, email ID, whatever the contact details, information has to be given, that can be added in the signature. So then comes your attachment, proper attachment that has to be done. So here there are various settings that is there, general settings. We tend to make a lot of mistakes in terms of grammar, in terms of spelling. So there is an inbuilt setting which is there in general, where you can able to enable that in terms of to check the spelling, to check the grammar and correct it. So, or we have a tool, or most of you are aware of this tool which is called as Grammarly. So this tool which helps us to identify any kinds of grammatical error or spelling error that can be corrected. So make sure that you're going to use either any of this tool or on this grammar suggestion or spelling suggestions, as when we are crafting an email, it will rectify any corrections, grammatical errors or spelling errors that can be corrected. So another setting what we have is default text style. Here, when we are crafting an email, we'll be confused what to put in the email body or subject line. So we tend to use AI tools, various AI tools, or we are going to search in the Google and take the content from various sources and keep pasting there. So here when we are pasting it, we'll forget to format it or we'll forget to change the font style and size. We are going to keep it very, I mean, the moment they receive the email, it will clearly evident that the information is being copied from the various sources. So avoid such mistakes. Have a default text style that clearly be evident that you are very professional in terms of crafting an email. Here, there is one option which is called as a vacation responder. If you see, there is option which is called as vacation responder. Suppose I'm not available in the college or in the company for a few days, I'm going for a vacation, but responding promptly to the emails which we are going to receive is highly appreciated. So because of that, you can enable this option. You can say when to when and give a content and enable it. Any email comes, automatically it sends a reply. Whatever the template you are going to draft, it automatically sends an reply to those emails. So this is how, when you craft an email, when you click on compose, this is a window you are going to get where signature is added in. So there's one more option where you can do a spelling check exclusively if you are not going for the general settings. So what are the various professional email etiquettes when we are crafting an email, when we have to draft and send an email, when we have to reply it? So these are the points that explains about our professional email etiquettes. Though we are angry, we don't want to show it in terms of when we are responding to. We might receive an email which shows a kind of frustration and anger, but we don't want to reply in a same tone. So keep a professional tone. Avoid using all capital letters in your email. That's the first thing that you have to keep in mind. And any kind of spelling errors, grammatical errors, avoid making such errors. So that clearly indicates that you are not meticulously planning and drafting an email. So create a professional email signature. As I told, you can have 2 or 3 professional email signature, add in, and based on whom you are addressing to, accordingly you can choose the email signature and send it. We are very fond of using emojis in the messages, in the WhatsApp. We want to show or express our emotions. So we want to give thumbs up. So avoid using those emojis in your email when you are sending an email. Properly structure your email. Have a bullet points, simple, concise, keep that flow, and always have a small subject line. Don't dump too much of information in the subject line. And whenever we receive an email, promptly respond, acknowledge for that email if your email ID is in to. So if it is in CC, that is only for your information. So when we are sending an email, make sure that you are attaching a document. Now we have option when we are sending an email without attachment, it reminds us saying that attachment is missing. So avoid sending emails without attachment by mentioning that email has a attachment. So make sure that don't add too vague subject line and add saying that meeting, hi, hello. So avoid all those things. In a professional, when you're writing a professional email, make sure that you follow these do's and don'ts. So this is a professional email etiquette that clearly indicates which has to be completely avoided. You would have seen you will receive an email with no subject line, and in the body you will see, hey, using all short keys, so which is completely not acceptable in a professional setting. So this is an example to show that what is not allowed when we are writing an email. So skipping the subject line or starting very vague or using those short keys, so that has to be completely avoided. So moving on to, as I told, this is the subject line which so much of information has been dumped, which is not advisable to keep all the content in the subject line. So moving on to, that's about our email etiquettes, how we can able to craft an email, what are the various options that we can able to choose it, and how we can able to choose a simple subject line and have a concise, short, logical, structured email with a proper signing off, greetings and attachment, and make sure that you use this to CC, BCC very carefully and reply all, whether required or not, analyze, and before you send it, do a proofread and then send a email. So moving on to the next topic, what I've taken as to talk about is time management. So we know that all of us will have a common saying. We have so much to do, but we don't have a time. So many tasks are lined up, but we are not able to do it. So this is a common complaint all of us have, or finding it difficult to manage our time, because the main reason is we don't prioritize the task. So I'm going to talk about some of the strategy to manage the time effectively. So here you can see this is called as a 2x2 cross matrix, two-dimensional matrix. What we are going to call it as, it's a time management matrix, which explains about how we can able to manage the time effectively. So this is called as a Eisenhower matrix. It has two dimensions. We see one is urgency, another one is importance. So let's, in the morning, list down what are the various tasks which we have to do for that particular day. So look at those tasks and decide which is very important, which would contribute to my performance or productivity, which is urgent, which requires my attention, immediate attention. So these are two dimensions what we have, importance and urgency. So importance, which would contribute to my performance or productivity, urgency, which requires my immediate attention. So based on this, you're going to decide which particular quadrant I have to fit in. If you say this particular task is very important and it is very urgent, which requires my attention, do that first. So these are 4 Ds what we have, which would help us to manage the time very effectively. So do it right now. If that particular task is very important, very urgent, do it right away. So there is another quadrant which talks about the tasks are very important but not urgent, which is important but not urgent. So you can decide, you can plan when you can do it. You can postpone it, you can decide when you can do it, because it is important but not urgent. So which doesn't require your immediate attention. Then we have this very urgent and but not important. So what you can take a help of others, you can delegate that task to others. If you say there is a normal reply has to be given for the client, so you can take a help of your colleagues or delegate that to your co-members, asking them to reply an email. So delegate it to others if that is important, but it is urgent, not important. There are tasks which are not at all important, not at all urgent. If you say our memory space is very full, I have to delete some of this documents. So we keep doing it, which is not at all important, which is not at all urgent. So we keep doing that, wasting our time. So those tasks has to be dumped it aside. Or browsing through a social media mindlessly, spending time there. So this has to be taken into consideration. So this model explains about 4 Ds that talks about a time management matrix, how effectively we can able to manage the time. Moving on to another strategy, which I'm going to talk about. Before that, you can see the list of topics, what I have mentioned here. You can see subjecting a project report due by end of the day. So it means end of the day, that reminds us the project is very important. At the same time, it is very urgent, which has to be done immediately. So finalize the presentation slides for pitch tomorrow. I have a presentation tomorrow. So I need to finalize what presentation I need to do, what are the slides I need to put in. So this is again important and it is very urgent because it is tomorrow itself. So I need to do it right away. There is another task which talks about updating your LinkedIn profile and resume for your career growth, which is important but not urgent. So you have to figure it out. If you have a list of tasks to do, which is important, which is urgent. Accordingly, you can take a decision which quadrant you have to fit in so that you can effectively manage your time. So you can decide when to do, you can delegate it, you can dump it, you have to do it. So this is another strategy to manage the time effectively, which is called as a Pomodoro technique. So it means, this is an Italian word which means tomato. So that's a shape of a timer, tomato. So here, this particular technique talks about have a small consistent effort that can lead to a bigger result. What that means, you have to have a list of tasks which you have to do it. Divide that into a different Pomodoros, fix the timings, take that one particular Pomodoro at a time, which can last for 25 minutes. After 25 minutes, take a break for 5 minutes. When you relax, when you decide the 25 minutes, they completely are going to focus on and do that particular task and take a 5 minutes break and continue again. So you can do that for 4 times, 4 Pomodoros, you can do it and take a long break. So that will help you to systematically organize, manage your time and complete the task. When you're fixing this 25 minutes, you have to make sure that there is no distraction. You are not getting deviated to other tasks. You have to fix that particular task for, time for that particular task. So if you make sure that this particular technique, works wonder for all of us. So that's about some of the time management matrix. So that's about a 2 aspect that defines about our professionalism at workplace. One is writing an email, how we have to craft an email effectively. And another one is how we have to manage the time effectively. If you have any questions.
Any questions from audience? Yeah, I don't think there are any questions from audience, Monica. Thank you very much for your interesting and informative session. This is very important. In today's scenario, managing time management is the biggest challenge for all the professionals. So in that context, I think your presentation was very informative and meaningful. And thank you on behalf of all the DT officials and all the faculty members here. I voluntarily thank you for your time and patience. Thank you. So we have a next speaker.
Thank you, sir.
Yeah, thank you. We have next speaker, Mr. Anil Kumar.
Yes, sir.
Yeah.
Yes, sir.
Yeah. So we have the next speaker, Mr. Anil Kumar from Government SKJTI, Bangalore. He was my ex-colleague in SKJTI. So today we'll be delivering talk on transform domain analysis in engineering applications. So he's from electronics and communication background. To introduce briefly about Anil Kumar T. He's assistant professor from Government SKJTI, Bangalore, and did this B from KIT, Victor, and Master of Engineering from UC, Bangalore. And he has got overall experience of 25 years of experience in teaching. And he has handled subjects such as signals and systems, DSP, analog and digital communication, etc. And he is already very well-known and popular teacher among all the students. So his lectures are very, very interesting, and hope even this presentation will be very, very interesting for all the participants. On behalf of all the staff members, I welcome you, Dr. Anil.
Thank you, sir. Thank you.
Yeah. You're given the option of sharing your slide.
Yes, sir.
You're given the option to share your slides. You can share.
Yes.
And you can switch on your video as well. You got PPT with you?
Note within, sir.
Yeah.
Full screen, aita?
It's clear.
Yes. Yes, sir.
And you can
ಎಲ್ರಿಗೂ ಆಗಿದೆಯಲ್ಲ ಸರ್?
ವಿಡಿಯೋ ಆಗಿಲ್ಲ, ವಿಡಿಯೋ ಆನ್ ಮಾಡಿ.
ವಿಡಿಯೋನಾ? ಡೇಟಾ ಇಲ್ಲಿ ಸ್ವಲ್ಪ ನೆಟ್ವರ್ಕ್ ಇಶ್ಯೂ ಇರುತ್ತೆ, ಪರವಾಗಿಲ್ವಾ?
Okay. Then you can continue without video, no problem.
ಅದಕ್ಕೆ ಸ್ವಲ್ಪಕ್ಕೆ ನಾನು ಇದು ಮಾಡಲಿಲ್ಲ.
No, not an issue. Continue.
Okay. ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. Good evening and all present in online mode. Myself Anil Kumar T, assistant professor from Government SKJTI. I am serving this teaching department from past 25 years, teaching subjects like signals and systems, DSP, communications, networks, and many more, which requires a strong basics of mathematical subjects. The students which they come to our colleges are really good. They have good marks of 90s, 99, 100 also. But when they listen to these subjects, then they try to learn these subjects, they lose some interest. Maybe they struggle to pass sometimes. They don't want to explore or how to bridge engineering subjects with mathematical subjects. So in this journey, I have inculcated some small methods to motivate my students. In this presentation, I'll be sharing them. My today's presentation topic is transform domain analysis in engineering application. First, analysis, the word analysis, why it is required. As we all do in our college, we do result analysis. After elections, department will do election result analysis, maybe before, maybe after. In our chemistry lab, we have performed salt analysis. Civil department will do structural analysis. Biology and medical department will do blood analysis. Why not our sports department? They do pitch analysis. All these analyses are done to extract some extra information present in that particular data. Like in sports, they guess, they predict what may be the run rate today, what may be the total score, how this team will perform, who may win. These are the statistical data they have, and they predict the results before the event occurs. In medical department, blood samples will tell about, blood analysis will tell about the root cause of some disease or what type of disease available or not. Like this, the raw data is observed and we comment some results. That is called as analysis of a data. But practically, we expect more information present in that particular data. If you want to get more information, we want to transform this data to the other domain. Something like in chemistry lab, if what they do is spectral analysis they will do, or they have an instrument called as spectroscopy, which is true in our medical department also. Like this, in our engineering applications, we have so many transform domain methods which gives wonderful results. The same results which we observed, we analyzed in the before, will give thousands more information for us. So by doing this, not only extra information, we get some extra qualities also. To understand what extra qualities that I get in transform domain analysis, I'll take one example. ನಾವೆಲ್ಲರೂ ಮೊಬೈಲ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ, ಒಂದು ಫೋಟೋ ಹೊಡಿತೀವಿ, ಒಂದು ಫೋಟೋ ಕ್ಯಾಪ್ಚರ್ ಮಾಡ್ತೀವಿ. ಫೋಟೋ ಕ್ಯಾಪ್ಚರ್ ಆದ್ಮೇಲೆ ನಮ್ಮ ಮೊಬೈಲು ಪ್ರೀ ಪ್ರೊಸೆಸಿಂಗ್ ಅಂತ ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ. ಆ ಪ್ರೀ ಪ್ರೊಸೆಸಿಂಗ್ ಮಾಡ್ಕೊಳ್ಳುವಾಗ ನಮ್ಮ ಫೋಟೋ ಅನಲಾಗ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇರೋದನ್ನ ಡಿಜಿಟಲ್ ಕನ್ವರ್ಟ್ ಮಾಡಿಕೊಂಡು ಬೇಕಾಗಿರೋ ಡೇಟಾನ್ ಮಾತ್ರ ಇಟ್ಕೊಂಡು ಬೇಡದಿರೋದನ್ನೆಲ್ಲ ತೆಗೆದಾಕಿ ಕಂಪ್ರೆಸ್ ಮಾಡಿ 1s and 0s ಫೈಲ್ ತರ ಸೇವ್ ಆಗ್ಬೇಕು. ಇಷ್ಟು ಕೆಲಸ ಪ್ರೀ ಪ್ರೊಸೆಸಿಂಗ್ ಅಲ್ಲಿ ಆಗುತ್ತೆ. ಕ್ಯಾಮರಾ ಕ್ಯಾಪ್ಚರ್ ಮಾಡ್ಕೊಳ್ಳೋ ಲೈಟ್ ಸಿಗ್ನಲ್ ನ ನಮ್ ಮೊಬೈಲು 1s and 0s ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. ನಮ್ ಲಕ್ ಚೆನ್ನಾಗಿದ್ದು ಒಂದು ಫೋಟೋ ಕ್ಯಾಪ್ಚರ್ ಆದ್ಮೇಲೆ ಈ ಪ್ರಾಸೆಸ್ ಮಾಡಕ್ಕೆ ಅರ್ಧ ಗಂಟೆ ಟೈಮ್ ಬೇಕು. ಅಷ್ಟುವರೆಗೂ ಕ್ಯಾಮ್ರಾ ನೆಕ್ಸ್ಟ್ ಫೋಟೋ ತಗೊಳಕ್ಕಾಗಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಯಾರು ಮೊಬೈಲೇ ಕೊಂಡ್ಕೊಳ್ಳಲ್ಲ. ಸೊ ದಟ್ ಇಸ್ ಅ ಡ್ರಾಬ್ಯಾಕ್ ನೌ. So what my transform domain will do is ಈ ಪ್ರಾಸೆಸ್ ಮಾಡೋ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ಕೆಲಸವನ್ನ ಕಮ್ಮಿ ಮಾಡುತ್ತೆ. ಸೊ ನಂಬರ್ ಆಫ್ ಕಂಪ್ಯೂಟೇಷನ್ಸ್ ರಿಕ್ವೈರ್ಡ್ ವಿಲ್ ಬಿ ರೆಡ್ಯೂಸ್ಡ್. If I reduce the number of computation, speed of processing increases. ಅರ್ಧ ಗಂಟೆ ತಗೊಳ್ತಿರೋ ಕ್ಯಾಮರಾ ಈಗ 10 ನಿಮಿಷಕ್ಕೆ ಇಳಿಯುತ್ತೆ. ಸೊ ಇನ್ನೂ ಸ್ವಲ್ಪ ಪ್ರೊಸೆಸ್ ಟೆಕ್ನಾಲಜೀಸ್ ಚೇಂಜ್ ಮಾಡಿದಾಗ ಆ 10 ನಿಮಿಷನ 10 ಸೆಕೆಂಡ್ಗೆ, 10 ಸೆಕೆಂಡ್ ಅನ್ನ 10 ಮಿಲಿ ಸೆಕೆಂಡ್ಗೆ ಅಥವಾ ಮೈಕ್ರೋ ಸೆಕೆಂಡ್ಸ್ ಇಳಿಸಿದ್ರೆ ನಮ್ಮ ಕ್ಯಾಮ್ರಾ ಕ್ವಾಲಿಟಿ, ನಮ್ಮ ಮೊಬೈಲ್ ಸ್ಪೀಡ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಸೊ my transform domain analysis will reduce the number of computation. If number of computations are reduced, speed increases. ಇಷ್ಟು ಎರಡೇ ಆದ್ರೆ ಸಾಕಾಗಲ್ಲ. ಆ ಕ್ಯಾಪ್ಚರ್ ಮಾಡಿರೋ ಡೇಟಾನಲ್ಲಿ ಇರುವಂತ ನಾಯ್ಸ್ ತೆಗಿಬೇಕು, ನಾಯ್ಸ್ ರಿಡಕ್ಷನ್ ಆಗುತ್ತೆ. ನಾಯ್ಸ್ ಕಮ್ಮಿ ಆದ್ರೆ ಕ್ವಾಲಿಟಿ ಚೆನ್ನಾಗಾಗುತ್ತೆ. ಕೆಲವು ನಾನು ತಗೊಂಡಿರೋ ಫೋಟೋನಲ್ಲಿ ಕೆಲವು ಇನ್ಫಾರ್ಮೇಶನ್ ನಮ್ಮ ಕಣ್ಣಿಗೆ ಕಾಣಿಸೋದೇ ಇಲ್ಲ. ಆ ಕಾಣಿಸದೇ ಇರೋ ಸಿಗ್ನಲ್ ನ ಇಟ್ಕೊಳ್ಳೋದು ಯಾಕೆ? ತೆಗೆದು ಹಾಕ್ಬಿಟ್ರೆ ಡೇಟಾ ಕಂಪ್ರೆಸ್ ಆಗುತ್ತೆ, ನಮ್ಮ ಫೈಲ್ ಸೈಜು ಚಿಕ್ಕದಾಗುತ್ತೆ. ಸೊ ಇಷ್ಟು 5 ಅಡ್ವಾಂಟೇಜ್ಗಳು ನಾನು ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಡೊಮೈನ್ ಹೋದ್ರೆ ಮಾತ್ರ ಸಿಗುತ್ತೆ. ಸೊ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಡೊಮೈನ್ ಅನಾಲಿಸಿಸ್ ಇಸ್ ಕಂಪಲ್ಸರಿ ಇನ್ ಆಲ್ ಇಂಜಿನಿಯರಿಂಗ್ ಅಪ್ಲಿಕೇಶನ್ಸ್. As an example, I have taken image. It is true for the other type of data also. ಸೊ ನಮ್ಮ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಟೀಚರ್ಸು ಇಷ್ಟು ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ಸ್ ಅನ್ನ ಹೇಳ್ಕೊಡ್ತೀವಿ. ಲ್ಯಾಪ್ಲಾಸ್, Z, Fourier transforms, discrete Fourier transforms, wavelet transforms, discrete cosine transforms, and many more. ನಾನು ಈ ಕೆಲವು ಎಕ್ಸಾಂಪಲ್ಸ್ ಅಲ್ಲಿ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಹೋಗಕ್ ಮುಂಚೆ ಏನ್ ಕಾಣಿಸಲ್ಲ, ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಡೊಮೈನ್ ಹೋದ್ಮೇಲೆ ಏನ್ ಕಾಣಿಸುತ್ತೆ ಅನ್ನೋ ರೀತಿಯಲ್ಲಿ ಈ ಪ್ರೆಸೆಂಟೇಶನ್ ಪ್ರಿಪೇರ್ ಮಾಡಿದ್ದೀನಿ. ಸೊ ಆ ಸ್ಟೂಡೆಂಟ್ಸ್ ತರ ಇಂಟ್ರೆಸ್ಟ್ ಕ್ರಿಯೇಟ್ ಮಾಡಬಹುದು ಅನ್ನೋ ಒಂದು ಪ್ರಯತ್ನ. ನಮ್ಮೆಲ್ರಿಗೂ ಗೊತ್ತಿರೋ ಪ್ರಕಾರ frequency. So one of the famous word in our domain, frequency. Regularly we say that frequency stands for number of cycles per second, number of repetitions per second. The time concept al heltivi. We have been taught that frequency means you check this one cycle. What is the time taken for one cycle? You take the inverse of that. That is the frequency. This is the calculation. Very good. If I come back to the next diagram, I can't measure time, one period for this. What is the frequency? ಅಂತ ಯಾರಾದ್ರೂ ಕೇಳಿದಾಗ ಆನ್ಸರ್ ಮಾಡಕ್ಕಾಗಲ್ಲ. ಅದ್ರ ಇನ್ನೊಂದು, ಇದು ಒಂದು ಗ್ರಾಫ್ ತಗೊಂಡಿದ್ದೀನಿ. Our voice is not an example of a wave, a periodic signal like this, which I have plotted here in red color. ನಮ್ ವಾಯ್ಸ್ ಯಾವಾಗ್ಲೂ ಎ ಪಿರಿಯಾಡಿಕ್ ಸಿಗ್ನಲ್ ಆಗಿರುತ್ತೆ. ನಮ್ ವಾಯ್ಸ್ ಅಲ್ಲಿ ಫ್ರೀಕ್ವೆನ್ಸೀಸು 300 ಹರ್ಟ್ಸ್ ಇಂದ 3400 ಹರ್ಟ್ಸ್ ವರೆಗೂ ಇರುತ್ತೆ. ಮೇ ಬಿ ಎ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ 2 ಕಿಲೋಹರ್ಟ್ಸ್ ಅಂದ್ರೆ ನಮ್ಮ ವೋಕಲ್ ಟ್ರ್ಯಾಕು 2000 ಸಲ ಓಪನ್ ಅಂಡ್ ಕ್ಲೋಸ್ ಆಗುತ್ತೆ 1 ಸೆಕೆಂಡ್ಗೆ, ನಮ್ಮ ಸೋನೋಮೀಟರ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಪ್ರಕಾರ. ಸೊ ಆ ಫ್ಲಿಪ್ ಆಗೋವಾಗ ಅದು ಯಾವಾಗ್ಲೂ ಎಲ್ಲಾ ವರ್ಡ್ಸ್ ಅನ್ನ ನಾವು ಒಂದೇ ಫ್ರೀಕ್ವೆನ್ಸಿಯಲ್ಲಿ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡಲ್ಲ, ಬೇರೆ ಬೇರೆ ಫ್ರೀಕ್ವೆನ್ಸಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ. 300 ಹರ್ಟ್ಸ್ ಇಂದ 3400 ವರೆಗೂ. ಅದನ್ನ ಹೆಂಗ್ ಮೆಜರ್ ಮಾಡೋದು ಈ ಸೆಕೆಂಡ್ ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ? ಇಟ್ ಇಸ್ ನಾಟ್ ಅಟ್ ಆಲ್ ಪಾಸಿಬಲ್ ಟು ಮೆಜರ್ ಇನ್ ದಿಸ್ ಸೆಕೆಂಡ್ ಡಯಾಗ್ರಾಮ್. ಸೊ ಐ ಮಸ್ಟ್ ಗೋ ಟು ಎ ಡೊಮೈನ್ ಕಾಲ್ಡ್ ಆಸ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಡೊಮೈನ್. ಈ ಸ್ಪೀಚ್ ಸಿಗ್ನಲ್ಗೆ ನಾನು ಫೋರಿಯರ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಅಂತ ಒಂದು ಲಾಜಿಕ್ ಒಂದು ಟೂಲ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ನನ್ನ ಸ್ಪೆಕ್ಟ್ರಮ್ ಈ ತರ ಕಾಣಿಸುತ್ತೆ. ಈ ಟ್ರಯಾಂಗಲ್ ಶೇಪ್ ಅಲ್ಲಿ ಇರಬಹುದು, ಆದ್ರೆ ಇದಕ್ಕೊಂದು ಮೀನಿಂಗ್ ಇದೆ. The zero frequency represents a DC component where our voice will not generate. It's a mathematical representation. ನಾವು low frequencies, something like 100 hertz, 200 hertz, ಇವೆಲ್ಲ ಜಾಸ್ತಿ ಆಂಪ್ಲಿಟ್ಯೂಡ್ ಅಲ್ಲಿ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತೀವಿ. ನಾವು ಮಾತಾಡುವಾಗ ಸ್ವಲ್ಪ ನಿಧಾನವಾಗಿ ಮಾತಾಡಿದ್ರೆ, ಅಂದ್ರೆ ಲೆಸ್ ಆಲ್ಫಾಬೆಟ್ಸ್ ಪ್ರೊಡ್ಯೂಸ್ಡ್ ಫರ್ ಮೋರ್ ಟೈಮ್ ಮಾಡಿದಾಗ ನಮ್ಮ ಆಂಪ್ಲಿಟ್ಯೂಡ್ ಅಂದ್ರೆ ವಾಲ್ಯೂಮ್ ಆಫ್ ವಾಯ್ಸ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ನಾವೇನಾದ್ರೂ ಸೇಮ್ ಟೈಮ್ ಅಲ್ಲಿ ಅಥವಾ ಕಮ್ಮಿ ಟೈಮ್ ಅಲ್ಲಿ ಜಾಸ್ತಿ ಆಲ್ಫಾಬೆಟ್ಸ್ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡಕ್ ಹೋದ್ರೆ ಅದನ್ನ ಹೈ ಫ್ರೀಕ್ವೆನ್ಸಿ ಕಾಂಪೊನೆಂಟ್ ಅಂತ ಕರಿತೀವಿ. ಆತರ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡಕ್ ಹೋದಾಗ ನಮ್ ವಾಲ್ಯೂಮ್ ಚಿಕ್ಕದಾಗ್ಬಿಡುತ್ತೆ, ಅಂದ್ರೆ ಆಂಪ್ಲಿಟ್ಯೂಡ್ ಕಮ್ಮಿ ಆಗುತ್ತೆ. So conclusion is lower frequency components will have higher amplitudes and higher frequency components will have lower amplitudes. ಇಲ್ಲಿ ಒಂದೊಂದು ಪಾಯಿಂಟ್ ಚೆಕ್ ಮಾಡ್ಕೋಬಹುದು, ನನ್ನ ವಾಯ್ಸ್ ಅಲ್ಲಿ ಯಾವ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇದೆ ಇಲ್ಲ, ಎಷ್ಟು ಆಂಪ್ಲಿಟ್ಯೂಡ್ ಇದೆ ಅಂತೆಲ್ಲ. ಈ ಫೆಸಿಲಿಟಿ ಸಿಗೋದು ಫ್ರೀಕ್ವೆನ್ಸಿ ಡೊಮೈನ್ ಅಲ್ಲಿ ಮಾತ್ರ. The frequency domain representation after Fourier transform, we call that as spectrum. ಅಲ್ಲಿ ಕೂತ್ಕೊಂಡು ಯಾವ್ಯಾವ ಟರ್ಮ್ಸ್ ಇದೆ ಇಲ್ಲ ಅಂತ ಚೆಕ್ ಮಾಡಿದ್ರೆ ಅದನ್ನ ನಾವು ಸ್ಪೆಕ್ಟ್ರಲ್ ಅನಾಲಿಸಿಸ್ ಅಂತ ಕರಿತೀವಿ. ಈ ಇನ್ಫಾರ್ಮೇಶನ್ ಈ ಸಿಗ್ನಲ್ ಅಲ್ಲಿ ಯಾವುದೇ ಕಾರಣಕ್ಕೂ ಕಂಡಿಡಿಯಕ್ ಆಗಲ್ಲ. ಸೊ ಯಾವ್ಯಾವ ಇನ್ಫಾರ್ಮೇಶನ್ ಅನ್ಸೀನ್ ಇರುತ್ತೆ, ಕಾಣಿಸೋದೇ ಇಲ್ಲವೋ, ಗೊತ್ತೇ ಆಗಲ್ಲ ಅಂತ ಇನ್ಫಾರ್ಮೇಶನ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಡೊಮೈನ್ ಅಲ್ಲಿ ಕಾಣಿಸುತ್ತೆ. ಸೊ ವಿ ಕ್ಯಾನ್ ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ದಟ್ ಇನ್ಫಾರ್ಮೇಶನ್. ಮೋರ್ ಇನ್ಫಾರ್ಮೇಶನ್ ಇಸ್ ಮೇಡ್ ಅವೈಲಬಲ್ ಫಾರ್ ಅಸ್. ಇದು one of the beautiful example because the world is completely digital. Any digital data is represented in a form of ones and zeros. A one in communication is represented by a rectangular pulse. ಸೊ ಸ್ಟೂಡೆಂಟ್ಸ್ ಇದಕ್ಕೆ ಫ್ರೀಕ್ವೆನ್ಸಿ ಹೇಳ್ರಪ್ಪ ಅಂತ ಕೇಳಿದ್ರೆ ಅದು ವೇವ್ ಫಾರ್ಮ್ ತರ ಇಲ್ವಲ್ಲ ಸರ್, ಅದಕ್ಕೆ ಫ್ರೀಕ್ವೆನ್ಸಿನೇ ಬರಲ್ಲ ಅಂತ ಹೇಳ್ತಾರೆ. ಸೊ ಇಲ್ಲೇ ರೆಡ್ ಕಲರ್ ಬರ್ದಿದ್ದೀನಿ, ದಿಸ್ ಸಿಗ್ನಲ್ ಇಸ್ ಎ ಪಿರಿಯಾಡಿಕ್ ಸಿಗ್ನಲ್. ಇಲ್ಲಿ ಒಂದು ಟೈಮ್ ಅಂತಿದೆ, ಒಂದ್ ಸೈಕಲ್ ಟೈಮ್ ತಗೊಂಡಿದ್ದೀನಿ, ಅದಕ್ಕೆ ಫ್ರೀಕ್ವೆನ್ಸಿ ತಗೊಂಡಿದ್ದೀನಿ. ನೋಡಿದ ತಕ್ಷಣ ಎಫ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 1/t ಅಂತ ಹೇಳ್ಬಿಡ್ಬೋದು. ಈ ಸಿಗ್ನಲ್ ಹೇಳಿ ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಂತ ಕೇಳಿದ್ರೆ ಇದು ಈ ತರ ಇಲ್ಲ, ಮಾಡಕ್ಕಾಗಲ್ಲ ಅಂತಾರೆ. So again I can tell that this has some frequencies, but that information is available only if I apply transform for this. One of the transform I have applied for this is Fourier transform. If I apply Fourier transform for this rectangular pulse, maxwell rectangular pulse, so ನಮ್ಮ digital world ಅಲ್ಲಿ it's a data ones and zeros transmitted. ಈಗ ನಾವು ಡೇಟಾ ಅಂತ ಹೇಳಿದಾಗ ಈ ಡೇಟಾ ಒಂದು ಬಿಟ್ ಡೇಟಾ, ದಿಸ್ ಇಸ್ ಐ ಹ್ಯಾವ್ ಟೇಕನ್ ಎಕ್ಸಾಂಪಲ್ ಆಫ್ 1 ಬಿಟ್ ಡೇಟಾ. ಈ 1 ಬಿಟ್ ಡೇಟಾಗೆ ಫೋರಿಯರ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಹಾಕಿ ನೋಡಿದಾಗ ವಿ ಗೆಟ್ ಎ ಸಿಂಕ್ ಫಂಕ್ಷನ್. ದಿಸ್ ಸಿಂಕ್ ಫಂಕ್ಷನ್ ಎಕ್ಸಿಸ್ಟ್ ಫ್ರಮ್ -infinity to +infinity. ನಾನು ಮ್ಯಾಟ್ಲ್ಯಾಬ್ ಅಲ್ಲಿ ಆಗಿರೋದನ್ನ ಲಿಮಿಟ್ ಅಲ್ಲಿ ತಗೊಂಡಿದ್ದೀನಿ. ಸೊ ಇಟ್ ಬೇಸಿಕಲಿ ಇಟ್ ಎಕ್ಸಿಸ್ಟ್ ಫ್ರಮ್ -infinity to +infinity. ಹಾಗಾದ್ರೆ ವಾಟ್ ಫ್ರೀಕ್ವೆನ್ಸೀಸ್ ಇಟ್ ಹ್ಯಾಸ್ ಅಂತ ಕೇಳಿದ್ರೆ it has all the frequencies from 0 to infinity. So ideally, bandwidth required to transmit one pulse, ಒಂದೇ ಒಂದು ಬಿಟ್ ಕಳಿಸಕ್ಕೆ ಇನ್ಫೈನೈಟ್ ಬ್ಯಾಂಡ್ವಿಡ್ತ್ ಬೇಕು. ಬಟ್ ನಾವು ಆಕ್ಚುಲಿ ಮಾತಾಡೋದು ವಿ ಸೆಂಡ್ ಗಿಗಾಬಿಟ್ಸ್ ಮೆಗಾಬಿಟ್ಸ್ ಇನ್ ಸೆಕೆಂಡ್. ಹೌ ಇಟ್ ಇಸ್ ಡನ್, ವಾಟ್ ಇಸ್ ಡನ್ ಅಂತ ನೋಡುವಾಗ ಮ್ಯಾಥ್ಸ್ ಅವ್ರು ಹೇಳ್ತಾರೆ ದಿಸ್ ಪೋರ್ಷನ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಸಡನ್ ಡಿಸ್ಕಂಟಿನ್ಯೂಟಿ. 1 ಇಂದ 0ಗೆ ಸಡನ್ ಆಗಿ ಫಾಲ್ ಆಗ್ತಿದೆ. ಈ ಸಡನ್ ಡಿಸ್ಕಂಟಿನ್ಯೂಟಿ ಇನ್ ಸಿಗ್ನಲ್ ಗಿವ್ಸ್ ರೈಸ್ ಟು ಹಾರ್ಮೋನಿಕ್ಸ್ ಇನ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಡೊಮೈನ್. ಅಲ್ಲಿ ಸಾಕಷ್ಟು ಫ್ರೀಕ್ವೆನ್ಸೀಸ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಅಂತ ಟೈಮಲ್ಲಿ ನಾವು ಈ ಪಲ್ಸ್ ಅನ್ನ ರೀಶೇಪ್ ಮಾಡಿದಾಗ, ಈ ಹಾರ್ಮೋನಿಕ್ಸ್ ಕಮ್ಮಿ ಆದಾಗ, ದೆನ್ ವಿ ಗೆಟ್ ಎ ಫೈನೈಟ್ ಬ್ಯಾಂಡ್ವಿಡ್ತ್. thereby we are achieving large data transmission in available bandwidth. ಸೊ ಈ ತರ ಒಂದ್ ಸ್ವಲ್ಪ ಇಂಟ್ರೆಸ್ಟ್ ಅನ್ನ ಕ್ರಿಯೇಟ್ ಮಾಡಬಹುದು ಸ್ಟೂಡೆಂಟ್ಸ್ಗೆ ಅಂತ ಐ ಹ್ಯಾವ್ ಟ್ರೈಡ್. ಸೊ ದಿಸ್ ಇಸ್ ಅಬೌಟ್ Fourier transform for these two signals, a digital data and a speech. But one of the biggest drawback of Fourier is Dirichlet's condition, which says that the function should be absolutely integrable. The function should have finite number of discontinuities and maximas and minimas. ಈ ತರ ಫೋರಿಯರ್ ಫೇಲ್ ಆಗಿದ ತಕ್ಷಣ ನಾನು ಫ್ರೀಕ್ವೆನ್ಸಿ ಡೊಮೈನ್ ಬರಕ್ ಆಗಲ್ಲ ಅಂತ ಶಾಕ್ ಆಗಕ್ಕಾಗಲ್ಲ. ವಿ ಹ್ಯಾವ್ ಅನ್ ಆಲ್ಟರ್ನೇಟ್ ಸೊಲ್ಯೂಷನ್ ಫಾರ್ ದಿಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಲ್ಯಾಪ್ಲಾಸ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್. ಫೋರಿಯರ್ ಫೇಲ್ ಆದಾಗ ಲ್ಯಾಪ್ಲಾಸ್ ಹೇಳ್ತಾನೆ ನಾನ್ ನಿನಗೆ ಸಪೋರ್ಟ್ ಮಾಡ್ತೀನಿ, ಬಟ್ ವಿತ್ ಕಂಡೀಷನ್ಸ್. ದಟ್ ಕಂಡೀಷನ್ಸ್ ವಿಲ್ ಲರ್ನ್ ವಾಟ್ ಇಸ್ ದಟ್ ಕಂಡೀಷನ್ಸ್ ಟ್ರಾನ್ಸ್ಫರ್. To understand Laplace transform in a better way, very simple way, I have taken one circuit called as series resonant circuit, also called as RLC circuit. When we apply Kirchhoff's voltage law, KVL for this, we get an equation like L di by dt plus R into I plus 1 by C integral of I dt. Bad luck again. I have an integration, I have a differentiation. We call such problems as integro differential equation. Maths is again a simple, I don't want to handle both. Let us convert this to complete differential equation. So we will differentiate once both sides. So this becomes d square. This integration and differentiation will cancel. We say that highest power of differentiation is 2. It is called a second order differential equation. But I say in electronics class, I have two memory elements, L and C. L kuda memory itkolate, C kuda memory device. ಅದಕ್ಕೋಸ್ಕರ 2 ಮೆಮೊರಿ ಡಿವೈಸ್ ಇರೋದ್ರಿಂದ ಇದನ್ನ ಸೆಕೆಂಡ್ ಆರ್ಡರ್ ಅಂತ ಕರಿತೀವಿ. ಯಾವುದೇ ಒಂದು ನೆಟ್ವರ್ಕ್ ಅಲ್ಲಿ ಎಷ್ಟು ಮೆಮೊರಿ ಎಲಿಮೆಂಟ್ಸ್ ಇದೆಯೋ ದಟ್ ಬಿಕಮ್ಸ್ ದ ಆರ್ಡರ್ ಆಫ್ ದ ಸಿಸ್ಟಮ್, ಆರ್ಡರ್ ಆಫ್ ದ ಡಿಫರೆನ್ಷಿಯಲ್ ಈಕ್ವೇಶನ್. Solving this differential equation is really difficult, time consuming. Second order ಮಾಡ್ಬಿಡ್ತೀವಿ, 4th order, 10th order, 100th order differential equation ಬಂದಾಗ ಸಾಲ್ವ್ ಮಾಡಕ್ಕಾಗಲ್ಲ. ಯಾವುದೇ ಪ್ರೋಗ್ರಾಮಿಂಗ್ ಎನ್ವಿರಾನ್ಮೆಂಟ್ ಬೇಡ ಅನ್ನತ್ತೆ. Such time, if I apply Laplace transform, this integro differential equation will simply get converted to a simple algebraic equation. An algebraic equation is very easy to solve, less time consuming. I have proved as a one statement, in transform domain, complexity of computations can be reduced, which I am proving here that an integro differential equation can be converted to simple algebraic equation by applying Laplace transform. So somebody can argue, hey, why differential equation solve ಮಾಡೋದು ಅಷ್ಟೊಂದು ಕಷ್ಟ ಅಂತ. ಕಷ್ಟ ಅಂದ್ರೆ I should find out the characteristic equation, roots of the characteristic equation, complementary function for that, followed by particular integral, again constants. First order, second order I will do. If the order of the differential equation increases, the technology fails. Bessel functions comes to the picture to solve the solution, whereas Laplace simply converts all such equation, integral differential equations to algebraic, which is an advantage for us. Not only this, we have an advantage. Once this is done, our system, any system, will be represented in the form of a mathematics called as transfer function, a simple math, a numerator and denominator. Roots of the numerator are called as, the numerator could be a polynomial or in a factored form. Now, within the roots of the numerator are called as zeros anta karitivi. Denominator polynomial irbodu, adanna factor form madakondre poles anta karibodu. Iga s is a independent variable varying from minus infinity to plus infinity. ಯಾವುದೋ ಒಂದು ಟೈಮಲ್ಲಿ ಎಸ್ ಮೈನಸ್ P1 ತಗೊಂಡ್ಬಿಟ್ರೆ ಮೈನಸ್ P1 ಪ್ಲಸ್ P1 0 ಆಗ್ಬಿಟ್ರೆ 1/0 ಇನ್ಫಿನಿಟಿ ಪ್ರಾಬ್ಲಮ್ ಬರುತ್ತೆ. ಈ ಇನ್ಫಿನಿಟಿ ಪ್ರಾಬ್ಲಮ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಅಲ್ಲಿ ನಾವು ಇಂಜಿನಿಯರಿಂಗ್ ಅವರು ಸ್ಟೆಬಿಲಿಟಿ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಸ್ಟೇಬಲ್, ನಮ್ಮ ಸಿಸ್ಟಮ್ ಸ್ಟೇಬಲ್ ಆಗಿರಬೇಕು, ಪ್ರೋಗ್ರಾಮ್ ಕನ್ವರ್ಜ್ ಆಗಬೇಕು ಅಂದ್ರೆ ಯಾವುದೇ ಕಾರಣಕ್ಕೂ ಎಸ್ ಶುಡ್ ನಾಟ್ ಟೇಕ್ ಎ ವ್ಯಾಲ್ಯೂ ಮೈನಸ್ P1 ಅಂಡ್ ಮೈನಸ್ P2. ನೀವು ಕಂಟ್ರೋಲ್ ಮಾಡಬೇಕು, ನೋಡ್ಕೋಬೇಕು, ಅದು ಮೈನಸ್ P1 P2 ಮೈನಸ್ P2 ತಗೋಬಾರ್ದು. ಆ ತರ ನೋಡ್ಕೊಳ್ಳೋ ಕಂಡೀಷನ್ ಅನ್ನ ರೀಜನ್ ಆಫ್ ಕನ್ವರ್ಜೆನ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಝೀರೋಸ್ ತೊಂದರೆ ಇಲ್ಲ, ನನ್ನ ಆನ್ಸರ್ 0 ಆದ್ರೆ 0 is a finite number, but infinity is not a finite number. Maths infinity is not a finite number, is infinity ಅನ್ನೋ ಪ್ರಾಬ್ಲಮ್ ನಾವು ಇಂಜಿನಿಯರಿಂಗ್ ಅಲ್ಲಿ ಅನ್ಸ್ಟೇಬಲ್ ಅಂತ ಕರಿತೀವಿ. ಅನ್ಸ್ಟೇಬಲ್ ಇಸ್ ಟ್ರೂ ಇನ್ ಮೆನಿ ಇಂಜಿನಿಯರಿಂಗ್ ಅಪ್ಲಿಕೇಶನ್ ಅಂಡ್ ವಿ ಶುಡ್ ಟೇಕ್ ಕೇರ್ ದಟ್ we should not reach instability. So that's the beauty of again a Laplace transform to control whether it's a stable or unstable. ಈ ತರ ಕಾನ್ಸೆಪ್ಟ್ ಬರಬಹುದು. This about Laplace transform. So Fourier and Laplace both will help continuous ಅಥವಾ ಅನಲಾಗ್ ಸಿಗ್ನಲ್ಸ್ ಗೆ, ಅನಲಾಗ್ ಫಂಕ್ಷನ್ಸ್ ಗೆ, ಕಂಟಿನ್ಯೂಸ್ ಡೇಟಾಗೆ. ಬಟ್ ಅಗೇನ್ as I told you, today's world is full of digital. We want a transform for digital data. So ಈ ಡಿಜಿಟಲ್ ಡೇಟಾ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ಸ್ ಬೇಕು ಅಂದಾಗ we go behind an equation called as linear constant coefficient difference equation, short form LCCDE. Very important, very nice mathematics where your output depends on present input, past outputs. ಇದು ನಾನು ಸ್ಟೂಡೆಂಟ್ ಹೇಳುವಾಗ ಒಂದು ಸಣ್ಣ ಎಕ್ಸಾಂಪಲ್ ತಗೊಳ್ತೀನಿ. ನೀವ್ ಯಾರಿಗಾದ್ರೂ ಒಂದು ಸಹಾಯ ಹಸ್ತ ಚಾಚಬೇಕು ಅಂದ್ರೆ, ಹೆಲ್ಪ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ, ನಿಮ್ ತಲೆಯಲ್ಲಿ ಒಂದು ಈಕ್ವೇಶನ್ ಓಡುತ್ತೆ. ಯಾವ ಈಕ್ವೇಶನ್ನು? ಈಗ ನನಗೂ ಆ ಫ್ರೆಂಡ್ಗೂ ಹೇಗಿದೆ ಕನೆಕ್ಷನ್, ಒಳ್ಳೆ ಸಂಬಂಧ ಇದೆಯಾ ಇಲ್ವಾ? ನಿನ್ನೆ ಮೊನ್ನೆ ಕಷ್ಟಗಳಿಗೆ ಅವ್ರು ಹೆಲ್ಪ್ ಮಾಡಿದ್ರ, ರಿಯಾಕ್ಟ್ ಮಾಡಿದ್ರ ಇಲ್ವಾ? ನನಗೆ ಯಾವ ತರ ಹೆಲ್ಪ್ ಮಾಡಿದ್ರು? ಸೊ ಎಕ್ಸ್ ಆಫ್ ಎನ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ಪುಟ್, x of n-1, n-2, n-3 previous inputs, n-1, y of n-1, y of n-2 ಇವೆಲ್ಲ ಪಾಸ್ಟ್ ಔಟ್ಪುಟ್ಸ್. ಸೊ ಪ್ರೆಸೆಂಟ್ ಟೈಮ್ ಅಲ್ಲಿ ನಾನೊಬ್ಬರಿಗೆ ಹೆಲ್ಪ್ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ ನನ್ನ ತಲೆಯಲ್ಲಿ ಇಷ್ಟು ಟರ್ಮ್ಸ್ ಓಡುತ್ತೆ. ಅದನ್ನ ಮ್ಯಾಥ್ಸ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬರೀಬೇಕು ಅಂದ್ರೆ ದಿಸ್ ಇಸ್ ದ ಒನ್ ಅಂಡ್ ಓನ್ಲಿ ಬ್ಯೂಟಿಫುಲ್ ಫಾರ್ಮುಲಾ ಕಾಲ್ಡ್ ಆಸ್ ಲೀನಿಯರ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಕೋಎಫಿಷಿಯಂಟ್ ಡಿಫರೆನ್ಸ್ ಈಕ್ವೇಶನ್. ಕೆಲವರು ಆರ್ಗ್ಯೂ ಮಾಡ್ತಾರೆ, ನಾನು ಹಳೆದೆಲ್ಲ ನೆನಪಿಟ್ಕೊಳ್ಳಲ್ಲ, ಇಟ್ಕೊಳ್ತೀನಿ ಅಂತ. ಅದ್ರ ಮೇಲೆ ನಾವು ಸಬ್ಜೆಕ್ಟ್ ನೇ ಚೇಂಜ್ ಮಾಡ್ತೀವಿ. ಹಳೆ ಫೀಡ್ಬ್ಯಾಕ್ ಬೇಡ ಅಂತಂದ್ರೆ ಇಟ್ಸ್ ಎ ಫೀಡ್ ಫಾರ್ವರ್ಡ್ ನೆಟ್ವರ್ಕ್. ವಿ ಡಿಪೆಂಡ್ ಓನ್ಲಿ ಆನ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ಪುಟ್ ಅಂಡ್ ಪಾಸ್ಟ್ ಇನ್ಪುಟ್ಸ್. ಇಲ್ಲ ನಾವು ಫೀಡ್ಬ್ಯಾಕ್, ಹಳೆ ಫೀಡ್ಬ್ಯಾಕ್ ಮೇಲೆ ಮಾಡ್ತೀವಿ ಅನಾಲಿಸಿಸ್ ಅಂದ್ರೆ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ IIR ಫಿಲ್ಟರ್ಸ್. ಸೊ ನಮ್ಮ ಡಿಸಿಷನ್ ಮೇಕಿಂಗ್ ಅಲ್ಲಿ ಎಲ್ಲಾ ಟರ್ಮ್ಸು ಇರಬಹುದು, ಬರೀ ಪ್ರೆಸೆಂಟ್ ಇನ್ಪುಟ್, ಪಾಸ್ಟ್ ಇನ್ಪುಟ್ ಇರಬಹುದು, ಅಥವಾ ಪಾಸ್ಟ್ ಔಟ್ಪುಟ್ಸ್ ಕೂಡ ಇರಬಹುದು. ಬೇಸ್ಡ್ ಆನ್ ಆಲ್ ದಿಸ್ ಪ್ಯಾರಾಮೀಟರ್ಸ್ ವಿ ಕ್ಯಾನ್ ಮಾಡೆಲ್. ಐ ಕ್ಯಾನ್ ಸಿಂಪ್ಲಿ ಸೇ ದಟ್ ಅವರ್ ಬ್ರೈನ್ ಕ್ಯಾನ್ ಬಿ ಮಾಡೆಲ್ಡ್ ಯೂಸಿಂಗ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಈಕ್ವೇಶನ್ ಕಾಲ್ಡ್ ಆಸ್ ಡಿಫರೆನ್ಸ್ ಈಕ್ವೇಶನ್ಸ್. ಹಾಗಾದ್ರೆ ಈ ಡಿಫರೆನ್ಸ್ ಈಕ್ವೇಶನ್ ಕೂಡ ಸಾಲ್ವ್ ಮಾಡಕ್ಕೆ ನಮಗೆ ಕೆಲವು ಮ್ಯಾಥಮೆಟಿಕಲ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಡೊಮೈನ್ಸ್ ಬೇಕು. ಡಿಸ್ಕ್ರೀಟ್ ಡಿಜಿಟಲ್ ಸಿಗ್ನಲ್ಸ್ ಗೆ ಇರೋದು discrete Fourier transform equivalent to continuous Fourier transform. I have discrete time Fourier transform. Bad luck of DTFT, the spectra becomes continuous. So what we do is we sample it and we develop one more transform called as discrete Fourier transform. ಇದು ನಮ್ಮ ಎಲ್ಲ ಡಿಜಿಟಲ್ ಡೇಟಾನ ಫ್ರೀಕ್ವೆನ್ಸಿ ಡೊಮೈನ್ ಕನ್ವರ್ಟ್ ಮಾಡಿ ಪ್ರಾಸೆಸ್ ಮಾಡಿ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ಕಮ್ಮಿ ಮಾಡಿ ಸ್ಪೀಡ್ ಜಾಸ್ತಿ ಮಾಡಿ ಕೊಡುತ್ತೆ. ಟು ಆಡ್ ಒನ್ ನೋಟ್, DFT ಫಾರ್ ಪ್ರಾಬ್ಲಮ್ ಮಾಡಿದಾಗ ನಮ್ಮ ಇಮೇಜ್ ಆಫ್ 1024 ಕ್ರಾಸ್ 1024 ಪಿಕ್ಸೆಲ್ಸ್ಗೆ 40 ಲಕ್ಷ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ಸ್ ಬೇಕು. 40 ಲಕ್ಷ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ಸ್ ಬೇಕು. ನಾನು ಫಾಸ್ಟ್ ಫೋರಿಯರ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಅಂತ ಒಂದು ಮ್ಯಾಥಮೆಟಿಕಲ್ ಟೂಲ್ ಯೂಸ್ ಮಾಡಿಬಿಟ್ಟು ಅದರಲ್ಲಿ ಡಿವೈಡ್ ಅಂಡ್ ಕಾನ್ಕ್ವರ್ ಮೆಥಡ್ ಯೂಸ್ ಮಾಡಿಬಿಟ್ರೆ ಐ ಕ್ಯಾನ್ ರೆಡ್ಯೂಸ್ 40 lakhs multiplications to a simple 5,000 multiplications, which is again a great reduction, which has been proved using all these formulas and calculations. So FFT handles like all digital data to convert from time domain to frequency domain and for processing. ಇದು ಕೂಡ ಅಷ್ಟೇ. ಫೋರಿಯರ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಅಲ್ಲಿ ಸ್ವಲ್ಪ ಫೇಲ್ ಆಯಿತು, ಅಗೇನ್ ಡಿರಿಚ್ಲೆಟ್ ಕಂಡೀಷನ್ ಆಗಲ್ಲ ಅಂತ ಹೇಳಿದ ತಕ್ಷಣ Z ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಹೆಲ್ಪ್ ಮಾಡಕ್ ಬರುತ್ತೆ. Again, it tells with a conditions called as region of convergence. Z transform is specially developed for discrete or digital data. Z transform is developed for digital data. Again, numerator polynomial, denominator. Again, they are zeros. This is poles. Poles are dangerous for us. Control them. If poles are there, system will have a very good quality. Feedback is very important for us. Without feedback, we can't improve ourselves. Similarly, in technology, engineering applications, feedbacks are really important, but we should control those feedbacks. So this denominator is required. But bad luck, sometimes denominator becomes zero. So something by zero becomes infinity. Controlling is called as region of convergence. Luckily, all this concepts which I have discussed till now in digital domain can be implemented using small hardware called as additions, multiplications, and delay. This is called as delay. This is called as multiplication. This is called as additions. So any engineering problem in the world, can be brought down to only two problems: multiplication problem and addition problem. Only thing is you want to convert them to additions, multiplications. So we call them as sum of product. Sum is addition, products are multiplications. Can be civil department structural data, medical department data, or a speech signal, or a image, or an Excel sheet generated from exit poll results. Any data can be, any processing could be, but inside hardware, it feels like it is multiplication problem and addition problem. So all this multiplication problem and addition problems can be implemented using three basic elements: adder, multiplier, and there is a delay element here. We call them as shifting. So coming to this small applications, as I was saying, so you tell me any engineering problem, I will convert that into a mathematical problem. All that mathematical problems can be converted to arrays, matrix form. Then all this could be implemented using a specific IC, dedicated IC designed for our applications called as custom design. We call them as ASIC, application specific integrated circuit. Is it for consumer electronics? Is it for industry, or our communication, or for healthcare? I say that VLSI has a solution to give a IC which will work with very high speed, very good quality, less power consumption, etc. So to support all these calculations, to understand, to simulate in an engineering domain, we have wonderful softwares like from C till Python. 25 years back, we were trying all this in C language. Then lot of toolboxes were supported in MATLAB. Nowadays, Python gives solutions for all such mathematical problems. Before I conclude, I want to say something. ಒಂದು ಇಂಜಿನಿಯರ್ಗೆ ಸಾಯಂಕಾಲ ಒಂದು ಮಲಗಿದ್ದಾಗ ಒಂದು ಒಳ್ಳೆ ಕನಸು ಬೀಳಬೇಕು. ಬೆಳಗ್ಗೆ ಇದ್ದಾಗ ಆ ಕನಸನ್ನ ಒಂದು 4 ಶೀಟ್ ಇಂಗ್ಲಿಷ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. ಆ ಇಂಗ್ಲಿಷ್ಗೆ ಒಂದು 10 ಬ್ಲಾಕ್ಸ್ ಬರೆದು ಒಂದು ಬ್ಲಾಕ್ ಡಯಾಗ್ರಾಮ್ ಪ್ಲಾಟ್ ಮಾಡಬೇಕು. ಪ್ರತಿಯೊಂದು ಬ್ಲಾಕ್ಗೂ ಒಂದು ಮ್ಯಾಥಮೆಟಿಕಲ್ ಈಕ್ವೇಶನ್ ಫಿಟ್ ಮಾಡಬೇಕು, ಕರ್ವ್ ಫಿಟ್ಟಿಂಗ್ ತರ. ಆ ಪ್ರತಿಯೊಂದು ಮ್ಯಾಥಮೆಟಿಕಲ್ ಈಕ್ವೇಶನ್ ಅನ್ನ ಪ್ರೋಗ್ರಾಮ್ ಅಲ್ಲಿ ರನ್ ಮಾಡಬೇಕು. ಈ ರನ್ ಮಾಡಿ ಆನ್ಸರ್ ಬಂದ್ರೆ ಇದು ಪ್ರಾಡಕ್ಟ್ ಆಗಿ ಮಾರಬಹುದಾ ಅಂತ ಥಿಂಕ್ ಮಾಡಬೇಕು. ಮಾರಿದ್ರೆ ಸೊಸೈಟಿಗೆ ಯೂಸ್ ಆಗತ್ತಾ, ಕಂಪನಿಗೆ ದುಡ್ಡು ಬರುತ್ತಾ ಅಂತ ಯೋಚನೆ ಮಾಡಬೇಕು. ಆಗತ್ತೆ ಅಂತಂದ್ರೆ VLSI ಇಂಡಸ್ಟ್ರಿ ಅದಕ್ಕೊಂದು ಚಿಪ್ ಮಾಡ್ಕೊಡುತ್ತೆ. ಆ ಚಿಪ್ಗಳನ್ನ ಮಾರಿದಾಗ ಅದೇ ಪೇಟೆಂಟ್ ಆಗತ್ತೆ, ಅದೇ ಇಂಟರ್ನಲ್ ರೆವಿನ್ಯೂ ಬರುತ್ತೆ, ದೇಶಕ್ಕೆ ಸೇವೆ ಆಗತ್ತೆ. ಅಂತ ಒಂದು ಪ್ರಾಡಕ್ಟೇ ನಮ್ಮ ಮೊಬೈಲ್ ಕೂಡ. ಸೊ ಇಷ್ಟ ಹೇಳಕ್ಕೆ ಟೈಮ್ ಕೊಟ್ಟಿದ್ದಕ್ಕೆ ಎಲ್ರಿಗೂ ಧನ್ಯವಾದ ತಲುಪಿಸ್ತಾ ಇದ್ದೀನಿ. ಸ್ಪೆಷಲ್ ಥ್ಯಾಂಕ್ಸ್ ಟು ಬಸವರಾಜ್ ಸರ್. ಸರ್ ಹಲೋ 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 ಸರ್.
Any questions from audience? Yeah, I think there are no questions. Thank you very much, Anil Kumar, for
Thank you, sir.
talk. And on behalf of all the officials and participants, I thank you for your time and your efforts.
Thank you so much. Thank you, sir.
Yeah. So we have next speaker.
Hello.
Murthy sir.
Yes, sir.
Yeah, sir.
I'm here.
Just one second. Yeah. Sir, it's actually it's our pleasure to have you on such a esteemed speaker on this occasion. We have today,
Thank you so much.
yeah, Dr. S.K. Murthy, and he'll be talking on progress, patent for progress.
Okay.
Yeah,
Yeah.
he was actually a founder and managing partner from Satyatam Kirtam Legal Solutions LLP, Bangalore. And on behalf of all the officials of DTE and participants, sir, I warmly welcome you, sir. And sir, our
Thank you so
pleasure
much.
to have you on this particular platform. And hope our participants will be enlightened by your presentation on IP. Thank you.
Yeah.
Please
Yeah.
continue.
Thank you so much, sir. Good evening, all. My name is S.K. Murthy, and I'm an engineer and a lawyer by training. I was with Intel for 20 plus years, and 15 days back, I quit Intel to start my own organization, a law firm basically, which focuses on innovation and patents. So, Basuraj sir, thank you so much for the opportunity. And in the next 30 minutes or so, I would like to introduce, I would like to talk about innovation. I would like to talk about IP basically, and especially focusing on patents. And
Sir, it's our pleasure. Sorry to interrupt you. I just briefly, I think I didn't get the complete profile of yours. It's my
That's
duty
okay.
to just share about your achievements.
No.
And happens to be myself and S.K. Murthy, we are Master of Engineering from the same institute, UC Bangalore. And we are batchmates. And he was from Electronics and Communication, and I am from Computer Science. And he stopped Electronics and Communication batch, and was very bright student at that time. And happens to be, he has worked in Intel for 20 plus years, as he was claiming. And later, actually, he has started his own firm in intellectual property. And definitely, sir, actually, we have a separate, dedicated nodal IP center at DT office. Now we are catering all the colleges covering diploma, engineering, and degree colleges. So your expertise and support is very much expected. And hope we will going to handhold our steps and take it.
Definitely, sir. It will be a pleasure to get involved with you on it.
Yeah, thank you. Yeah.
So today, since this is the first session, I would like to talk about few basics of intellectual property, basics of patents, and definitely there are so many advanced topics. And in subsequent forums like this, in subsequent programs like this, we can talk about more advanced topics. But to start with, we will get to understand the basics of intellectual property, and we will also talk about patents in specifics because you all come from a very rich technical background. Patents would be more relevant as compared to other flavors of intellectual property. So I would focus on patents more. But to start with, I'll talk about the various flavors of intellectual property and the corresponding intellectual property rights, and then come to patents. So if you look at intellectual property, at a very high level, we can say intellectual property is a creative output of the mind. Whatever is the creative output of the mind can be called as intellectual property. And there are several flavors of intellectual property, or several buckets within intellectual property. One of them could be inventions. I'm only talking about such flavors of intellectual property which has a corresponding legal right uh, to this intellectual property. So if you look at various buckets within intellectual property, inventions would be one of the buckets and a major bucket. And what does an invention do? Invention is basically a patentable invention is basically uh, deeply functional in nature, right? It has to have functionality. Functionality is the king when it comes to inventions. And if this invention satisfies certain criteria, then the government will give you a right for a limited period of time, and that particular right is known as patents. We will look at what is the criteria, how long, what is the process, and if a right is granted, what is it actually that you would get, and how long is this right valid? All those things we will talk about when we get deep into patents. The second flavor of intellectual property is literary, artistic, dramatic works, and computer programs per se. All these things fall under a category known as literary, artistic, and dramatic and computer program works. These are copyrightable works, and the legal right that protects all this kind of work, as long as they are original creations, would be called as copyrights. And when you have logos and um, marks and sounds associated with a particular logo, then those are called trademarks. Trademark is the legal right that protects this kind of creative output of the brain, creative output of the mind. There are also something known as designs. In India, we call it industrial designs. And when we are talking about industrial designs, this would add to the aesthetic value of the product. It is appealing to the eyes, but it is not having any functionality. It does not have functionality, but it is appealing to the eyes. Just to give you an example, if I have a coffee mug and if there is a handle attached to the coffee mug, handle has functionality, right? So when you design a handle, it has functionality. And if you come up with a fantastic design of the handle, that could be in the area of patents rather than designs. But on this handle, if you make a painting, right, a beautiful color combination of a sketch, and if that appeals to the eyes of the user, and if it enhances the value of the product, those things, as long as they are original and novel, they can be protected by industrial design rights. So these are some of the major flavors of intellectual property. And another flavor of intellectual property is trade secrets, where you keep a certain technology as a secret. Those things can be protected by trade secrets. Of course, there are several countries which have their own trade secret law, but India is not there yet, in the sense that we have been discussing to have a trade secret law in India, but as of now, there is no trade secret law, right? So these are some of the flavors of intellectual property. And if you look at the time of protection, if you look at the span of protection for each of these intellectual property rights, if I have an invention, if it is protected by a patent, you have 20 years of exclusive rights to get a return on investment for your patents. And 20 years is counted from the date of filing of the patent application, not from the date of grant. It is from the date of filing of the patent application, 20 years from the date of filing. So within these 20 years, definitely you would have put in a lot of resources, you would have put in a lot of creativity, you would have put in a lot of hard work. And if you get a patent on your invention, then you have 20 years to get a return on investment. And return on investment can be by productizing your patented invention or by licensing your patented invention. So the routes for commercialization might be different, but you have 20 years of limited period of time. If you have a copyright, if your literary, artistic, dramatic, and computer programs per se, if they are protected by copyrights, then it is the life of the author. The span of a copyright spans over the life of the author plus 60 years after the death of the author, or 70 years in some countries, right? So if I have a copyright on a book, then it is for my life plus 60 years after I die. So that is the time limit for the time limit of protection for the copyright. If you look at trademarks, once a trademark is granted to you, every 10 years it can be renewed, and it is perpetual in nature. As long as you keep renewing it, it can be there for any number of years. And for designs also 10 years. Once 10 years period expires, then there is no way to extend the time period of an industrial design. So these are some of the flavors of intellectual property. And when it comes to trade secrets, trade secrets can remain secret as long as you keep it as a secret. A fantastic example of a trade secret is the chemical composition of Coca-Cola. It has been a trade secret for more than 100 years. Nobody knows the exact chemical composition of Coca-Cola because the Coca-Cola management of Coca-Cola decided that, okay, we will keep this chemical composition as a secret. Okay. Now, looking at patents, what is a patent? As I already said, a patent is an intellectual property right which protects your invention. What should be the criteria for protecting an invention? If you look at the criteria for protecting an invention, your invention should be new as compared to what is already existing. I'll explain this a bit. So the first criteria is your invention should be new as compared to what is already existing and known to the world. Okay, so that is the first thing, novelty. Then it should have a use, right? Your invention should have a use, and this use should not be contrary to the public order, right? It should not be contrary to the public order. It should be helpful for the public. So first one is novelty, second one is use, third one is it should not be an obvious invention. It should not be obvious to a person of ordinary skill in the art. So these are the three things that the patent office would check or examine, and if these three things are satisfied, then a patent should be granted according to the patent law of this country. Okay, just to explain what it means, right? What do these things mean? Let us say I have a very small bottle here. Let us say whatever is known to the world in the form of written documents, publications, all these things, let us put it into this bottle, okay, this small bottle. When I say novelty, your invention should be outside this bottle and it should be new as compared to something which is already inside the bottle, right? So your starting point will be somewhere inside the bottle. From there, you make modifications, you make changes so that your invention falls outside the bottle, okay? So that is novel. Why should patents not be granted only based on novelty? That is the question, right? If patents are granted only based on novelty, then it is very easy for everybody to take something which is already existing inside this bottle and make some minor cosmetic modifications so that it becomes novel. So if rights are granted only based on novelty, then people would go and exercise these rights. And where do you exercise these rights? You exercise these rights in the courts of law. Then people would start spending more time in the courts defending their rights rather than doing the real actual R&D work or creative work. So the wisdom of the legislature is, of course, definitely it has to be outside this, but it should also be at a particular distance from this bottle. And this distance is a measure of the inventive step or non-obviousness. It should not be obvious to a person of ordinary skill in the art. What does person of ordinary skill in the art mean? If I am a computer science engineer, if there is an invention which somebody has come up, it should not be obvious to me. Let us say, I'll give you an example. If I have to implement an algorithm, there is a mathematical formula for this algorithm. I go use a computer to implement. It is obvious to everybody, right? Implementing it in a computer is there is no value that is added except that it is implemented in a computer, right? Of course, there is an innovation value to it, but from a patentability perspective, it looks very obvious. And the third one, as I said, it should have a use. So whenever you have an invention or whenever you start thinking of something new, you should think about whether my invention is new as compared to what is already existing. If you can clearly establish novelty, then there is a way forward to go get a patent on your inventions. Okay, so this is the criteria for patentability. For you to remember it easily, NUN, none, NUN, novelty, use, and non-obviousness. These are the three things that need to be remembered, which is the criteria for granting a patent. And the terminology that I used is the terminology that is used in the US, but throughout the world, patent laws use different terminologies to mean the same thing, right? For example, in India, novelty is novelty, use is defined by something known as capable of industrial application. So if your invention is capable of industrial application, it means that there is a use. If your invention is non-obvious, in India we call it inventive step. So non-obviousness in the US is equivalent to inventive step in the Indian context, right? So when it comes to Indian context, your invention should have novelty, it should be capable of industrial application, and it should have an inventive step. If these three things are satisfied, then a patent should be granted. And another requirement, though it is not a criteria, but a requirement, is patents are not granted for abstract ideas, right? If I come up with an idea that, okay, I can fly a car using H2O, this is a fantastic idea, right? It's a fantastic idea which has value, which has use, everything, and it's also non-obvious. But when you disclose it to the patent office, this idea should be supported by implementation details. Without the implementation details, you have not enabled your invention. So when we write a patent application, which is a 50, 60, 70 page document, we need to disclose all the special tricks, right? All these special tricks and implementation details that is required to implement your idea or reduce your concept into practice, right? That does not mean that you should have a working model or a proof of concept. You should be in a position to think through and disclose all that information in the patent application. So if these things are satisfied, then the patent office would grant you a patent. I'll give you an example for the implementation detail, right? Let us say the time was measured in an analog fashion earlier. Somebody came up with measuring the time in a digital way, right? And now it is not just sufficient to say that, okay, I am measuring time digitally, so that is my invention. That is at a very high level, a concept level. But you also have to disclose the implementation details. So in the implementation details, one way of implementing this concept or reducing this concept into practice could be, okay, I use an up counter, I use a positive edge triggered clock, and this positive edge trigger clock has a frequency of 60 hertz or something like that, right? So for a person like you, a person skilled as you are, if they read this document, they should be in a position to go implement it on their own after 20 years, right? Within these 20 years, if they have to implement, if somebody else has to implement, then they should come to you, ask your permission, take a license. And when you're granting a license, you can ask for royalty. All those things are possible. That is one way of commercializing your invention within these 20 years. What I'm trying to say is it is not just sufficient if you have an abstract idea, but you should also have implementation details of this invention, which should be sufficient enough to reduce your invention into a practice. So that is the requirement. If all these requirements are satisfied, then the patent office will grant you a patent. Let us look at the timeline a bit later, but once the patent is, now let us look at what do you get. If you get a patent, what is it that you get? So if you get a patent, it gives you a right. A patent gives you a right to stop somebody, right? This is the most critical word in this definition. It gives you a right to stop somebody. So stop somebody is the key operative word. So it gives you a right to stop somebody from making, using, selling, offering to sell, and importing the patented invention. So these are the 5 things that you can do when you have a patent. You can stop somebody from making, using, selling, offering to sell, and importing the patented invention. It is kind of a negative right. What I mean by negative right is if you come up with a fantastic invention and if you get a patent, it might not necessarily give you a right to practice it, right? It might not necessarily give you a right to practice your own invention, but what it definitely and necessarily gives you is a right to stop somebody from doing these 5 things. It looks counterintuitive. I'm saying that I came up with the invention, I got a patent right on this, and in spite of that, you are saying that it does not necessarily give you a right to practice. It looks counterintuitive, but I would like to give an example so that you understand this concept. Let us say there is a company A which was established in 2000. It started manufacturing combustion engines, okay, and it has a patent on the carburetor of the combustion engine. Now, this happened in 2000. A patent was granted, and based on this patent, this company A started manufacturing combustion engines, which had a carburetor designed by them, and a patent was granted to them. In 2003, an individual looked at this carburetor and said, okay, I can modify this carburetor so that it also works on gasoline, right? It also works on gasoline. So he took this carburetor, made some modifications, and after doing the modifications, he tested this carburetor by putting it into the combustion engine, and combustion engine started working well with gasoline. Now, this person B, he went to the patent office and he disclosed his invention to the patent office in the form of a patent application. And it satisfied all the 4 things that I said, 3 things plus 1 enablement, right? NUN plus enablement. So 4 things were satisfied and a patent was granted to B. So B has this patent on a modified carburetor which can handle combustion, which can handle gasoline. Now let us look at the options available for A and options available for B. Can A continue to manufacture combustion engines? What do you think? Can A continue to manufacture combustion engines? The answer is yes, right? A can continue to manufacture combustion engines. Can A manufacture gasoline combustion engines without getting permission from B? The answer is no, because if A starts manufacturing gasoline combustion engines without getting the permission of B, then he would be violating or infringing the patent rights of B. Okay. Now let us look at the options available with B. Can B manufacture gasoline combustion engines? The answer is no, because the base technology for the combustion engine, in particular the carburetor, is with A. What B did was took this carburetor and made some modifications. And those modifications on their own, modifications by themselves, were eligible for getting a patent. So if B has to manufacture gasoline combustion engines, he cannot manufacture combustion engines without getting permission from or a license from A to the combustion engine patent that A already has. So in this particular example, even though B had a patent on gasoline combustion engines, B could not manufacture it. That is what I was saying. If you have a patent, it may not necessarily give you a right to use your own or practice your own invention. But look at the next question. If A or anybody for that matter, if they start manufacturing gasoline combustion engines without seeking permission from B, what is the right that is associated with B, or what can B do? B can stop anybody from making, using, selling, and making, using, selling, offering to sell, and importing the patented invention. So B has an exclusive right against everybody in that particular geography. If B has a patent in India, B has an exclusive right on this patent, which can be used to stop anybody in India from using this particular invention, right? So if you look at this example, what B got was a right to stop others rather than getting a right to practice his own or her own invention, right? So this should be very clear. If I have a patent, I get a right to stop somebody from doing these 5 things. And as I said, the life of a patent is 20 years from the date of filing and not from the date of grant. Between the date of filing and the grant, there are several things that would happen. So if you file it on November 1st, 2000, right? After 18 months, the patent application will be published by the patent office. When you say the patent application is published, it means that the patent office is telling the world, that I have received a patent application and this is how the patent application looks like. Publication is not equal to grant. It is only a way of communicating. The patent office communicates to the world that it has received a patent application. And after 18 months, probably 4 or 5 months later, it would take it up for examination. When they are examining, they would look at whether your invention is novel. They would search all the databases available in the world, and they would carry on this examination, and the examination results are disclosed to you, right? It's not a black box. They would say why they are raising these objections and what is the basis for raising the objections. So they would do the searches, they would apply their mind, they would compare your invention with what they have found, and they will come to a conclusion whether your invention is novel or not. They would come to a conclusion whether your invention is a non-obvious invention or not, whether your invention has a use or not, whether it is enabled or not. And once that is done, they would send you a statement of objection, right? They would send you a statement of objection, and the applicant or the inventor has an opportunity to respond to that and tell why patent office, or if an applicant disagrees, then he can definitely say why he disagrees and why the patent office is wrong in its analysis. And if the patent office is convinced with your response, then a patent would be granted. And this would take around 3.5 years now, right? There was a time not so long ago, probably 15 years back or 11 years back, for grant of a patent, it would take 7 or 8 or 9 years. But today, there has been several changes, positive changes that has come into the patent office. The patent offices are modernized. Number of examiners are in the available number of examiners, well-trained examiners, has increased by almost 10 times, right? At one point in time, we had around 100 patent examiners. That was the maximum. Today, we have around 850 to 900 well-trained examiners. So the pendency has come down. You will be granted a patent in 3.5 years in most of the technologies and for most of the cases. So you have a patent, which is 20 years of life, and you have a right to protect your invention against any kind of infringement, and your patents would protect inventions And for an invention to be protected by a patent, it should be novel, it should have a use, it should be a non-obvious invention, and this patents are not granted for abstract ideas, they should be supported by implementation details. For today, this is what I could cover. These are some of the very, very basic things when it comes to patents. So once we have a good understanding about these basic things, we can start moving up and looking at more complex things when it comes to patents. I would stop here. If you have any questions, I'll be very happy to answer them. Thank you very much. Thanks for the opportunity. Dr. Basuraj, thanks a ton. If you have any questions, please let me know.
Any question from audience? Hello? If you have any questions from audience, I think you'll take up the questions.
Yeah, sure.
Sir, I think there are no questions, sir.
Okay.
So thank you very much for a wonderful session. Without
Yeah,
slides,
thank you.
continuously, you started talking, presenting to the audience. It shows that how much you are experienced and well-versed with the IP. So it's
Yeah.
really an honor to have you on.
Thank you, sir. Thank you very much.
So we need your support and guidance,
Sure,
sir.
anytime.
Always we'll be happy to collaborate with you. And
Sure,
once
sir.
again, on behalf of our higher officials of Higher Education Department and all the staff members, I thank you very much for your time, sir.
Thank you very much, sir. Thanks a ton. I'll come and meet you, sir. Thank you.
Next, the last speaker, we have Dr. Prashant from Government Engineering College also. Prashant?
Yes, sir.
No.
Yes, sir. Sir, I'm audible.
You're not audible. Yeah,
Yes,
you
sir.
are audible.
Yes, sir. Sir, I want to share the screen.
One second. Hello?
Yes, sir.
One second. Yeah, you'll be delivering today talk on second. Mechanical trends in the heat pipes, and working as assistant professor in the Department of Mechanical Engineering, Government Engineering College also. And to introduce briefly, Prashant is not shared his profile. Yeah. Anyway, on behalf of all the participants, I welcome you, Prashant. And
Yes,
I request you please continue your presentation.
Sir, is my PPT sharing?
No, you have to make it full screen visible. Open ಮಾಡಿ first. Screen open ಮಾಡಿ. PPT open ಮಾಡಿ. Open ಆಗಿಲ್ಲ. ಅಂದ್ರೆ ಇಲ್ಲ ಅಂದ್ರೆ you do want to close ಮಾಡ್ಬಿಟ್ಟು ಮತ್ತೆ share close ಮಾಡಿ. ಇದು one thing share ಮಾಡಿದ್ಮೇಲೆ you have to use entire screen.
Okay, sir.
Share ಮಾಡಿ ಮತ್ತೆ.
Third tab, entire screen.
ಮೂರನೇ ಟ್ಯಾಬ್ ಇದೆ ನೋಡಿ, ಅದನ್ನ ಎಂಟೈರ್ ಸ್ಕ್ರೀನ್ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ.
Sir.
ಈಗ ಓಪನ್ ಮಾಡಿ. ಈಗ ಫುಲ್ ಇದು ಮಾಡಿ. Now is visible. You can carry on.
Okay, sir. Thank you, sir. Sir, myself, Prashant, I'm working in Government Engineering College, Hassan as assistant professor. So today I'm going to do lecturing on mechanical trends in heat pipes. So first, I am going to discuss about the introduction about the heat pipe. So what is heat pipe and what are the applications of the heat pipe? And second thing, the researchers who have done the work on heat pipe, that is the second part. Then third one is the experiments, what I have done in my research work. Then fourth is the results and discussion, conclusions, then finally references I am going to show in my presentation. So coming to the introduction, sir. So due to environmental concern like global warming, high price of fuel, waste heat recovery has become a very crucial issue for the industrial and commercial energy users. So sometimes heat may be useful and sometimes heat has to go out. So we have different methods to exchange the heat, and one of the method is heat exchanger. Heat exchanger is also one of the effective device for waste heat recovery. So first of all, we should know what is a heat pipe. So heat pipe is a device which is going to transfer heat from one section to another section. So heat pipes are often referred to as the superconductors of heat. Okay, so as they possess extraordinary heat transfer capacity and rate with almost no heat loss. And the thing is, okay, heat pipes is a passive device. Uh, so you don't require any external power for the working fluid to move from one section to another section. This sketch shows you the conventional heat pipe and oscillating heat pipe. So in the conventional heat pipe, it consists of three sections: evaporator section, adiabatic section, condenser section. In the conventional heat pipe, we are going to have a wick inside the heat pipe. So in the evaporator section, heat will be absorbed by the working fluid and it starts moving from evaporator section to condenser section to adiabatic section. So in the condenser section, heat will be liberated from the working fluid to the external cooling medium. So, and finally again, the working fluid will be transferred to the evaporator section due to the gravitational force, and this process is going to continue in conventional heat pipe. So if you come to the oscillating heat pipe, even oscillating heat pipe also has three sections: evaporator section, adiabatic section, and as well as condenser section. So again, the working fluid will be filled inside the oscillating heat pipe. And in the evaporator section, heat will be generated. This heat will be absorbed by the working fluid which is there inside the heat pipe, and it will be transferred into the condenser section. So where in the condenser section, it undergoes a change of phase from vapor phase to liquid phase, and again the liquid will come back to the evaporator section through adiabatic sections, right? So here the thing is, in oscillating heat pipe, okay, so the heat absorption in the evaporator section is more than the conventional heat pipe, right? So if you want to show some of the differences between conventional heat pipe and oscillating heat pipe, so these are the differences. First one is, in conventional heat pipe, the capillary action is due to the wick structure, whereas in oscillating heat pipe, the capillary action is due to the pressure pulsation. Second one is, temperature drop is minimal in conventional heat pipe, whereas in oscillating heat pipe, the temperature drop is more compared to conventional heat pipe. That why it is because the conventional heat pipe operates only in the latent heat region. Latent heat is nothing but where the working fluid is undergo the change of phase from liquid phase to vapor phase. Whereas oscillating heat pipe, it works in two regions, that is sensible heat region as well as in the latent heat region. That is why more heat transfer capacity is having for the oscillating heat pipes. So the conventional heat pipe design and fabrication is simple, whereas oscillating heat pipe design methodology is yet to be explored, because people are working on oscillating heat pipe with different parameters. So still the design methodology is to be explored. So complete evaporation, okay, whereas that is why as I told you, conventional heat pipe operates only in the sensible heat, whereas oscillating heat pipe operates in both sensible heat region and latent heat region. So coming to the applications of oscillating heat pipe, these are some of the applications of the oscillating heat pipe. So especially in the electronic systems, heat will be generated, and this heat, if it is not within the minimum temperature, then the electronic system stops operating in the normal way. So there in the laptop computers, high performance processors, refrigeration systems, aerospace, okay, low maintenance and high reliability applications, and noise sensitive environments where heat can be dissipated to large remote heat sinks. So these are some of the applications of the oscillating heat pipe. Okay, so I forgot to mention, oscillating heat pipe sometimes is also referred to as pulsating heat pipe. This heat pipe was first invented by Akachi in the year 1990. So here, in my experiments, I have used nanofluids as the working fluid. So nanomaterials might be a composites, ceramics, polymers, or metals. Okay. So then here the nanoparticles can be mixed with the base fluid. The nanoparticles can be used are zinc oxide, copper oxide, aluminum oxide, etc. And the base fluids can be any other fluid which has a low boiling point. So for example, some of the base fluids are acetone, ethanol, and methanol, etc. So what are the advantages of nanofluids? So first thing, the nanofluids has improved heat transfer that provide following benefits over traditional solid liquid suspensions. First thing, highest specific surface area, as a result, largest surface area for the exchange of heat between the particles and the fluid. Excellent distribution consistency with predominance of Brownian particle motion. That is the second thing. Third one is the least amount of pumping power necessary to provide an increase in heat transfer compared to pure liquid. So these are the advantages of nanofluids. Okay, and as well as it has more surface wettability and more thermal conductivity, so which enhance the heat transfer. So actually, I have not discussed literature survey about individual persons. Just I have made only one slide about the literature survey, what the researchers are doing. So the several researchers have worked on oscillating heat pipe with various parameters like heat, inner diameter, fill ratio, okay, working fluid, orientation, and even number of turns. Okay. So they have all worked on different parameters to determine the performance of the pulsating heat pipes. And the experimental investigation reports, they focus on the flow visualization pattern, measurement of temperature, effective heat transfer, thermal conductivity, heat transfer coefficient. So these are the parameters they have found from the oscillating heat pipes. And also, researchers have found out that they have worked with different fill ratio from 20% to 80%. So what is fill ratio? That you should know first. The fill ratio means the volume of the heat pipe. So if you know the diameter of the heat pipe and the length of the heat pipe, area into length will give you the total volume of the heat pipe. So and if you, for example, if you are having 4.6 ml as the volume, if you are filling 2.3 ml, that is half. So it comes to 50% fill ratio. And if you take heat is also another parameter. Heat can be from 5 watt, 2 watts, 3 watts. Okay. So if I take, I have taken from 20 watts, 25 watts in steps of 5 watts till 40 watts. And the working fluid can be either conventional fluids like acetone, ethanol, methanol, or even it can be a nanofluids. And very few researchers have worked on refrigerants also. So that is one of the very important area where we can do research using refrigerant as the working fluids, because you know refrigerant is having a very low boiling point. So definitely heat transfer will be more in refrigerants. And also studies have found that if you are increasing the fill ratio, you are going to have more heat transfer. So this is the experiment. If you want to conduct any experiments on the heat pipe, first thing is you have to select the material for the heat pipe. Usually we go with copper because it is having more heat transfer capacity. And you have to do fabrication of the heat pipe, and then you have to select the working fluid. Okay, So the working fluid can be conventional fluid, nanofluids, or even it can be a refrigerants also. So in my experiments, we have taken conventional fluid as well as nanofluids. And nanofluids, these aluminum oxide and the zinc oxide, taking the concentration of the nanofluid with the base fluid. So, and also the after the fabrication of the oscillating heat pipe, we are going to conduct the test. Okay, so we need to have a data logger, heat applying device, then of course system is required. So every 2 seconds or once, depending on the data logger condition, so you can take every 2 seconds what is the temperature so in the evaporator section as well as in the condenser section. Based on that, you can calculate thermal resistance, heat transfer coefficients. So these are the very two important parameters in any heat transfer. This actually figure shows the experimental setup with the data acquisition system of OHP. Okay, so this is the heat pipe. Okay, and it has been covered with a glass, so you can see the downward side. That is a white color. You can see, I think, so that it prevents the heat transfer. This constitutes the evaporator sections. So here, what we have done is we have used the mica as the mica heater. So where it in the evaporator sections, and in the condenser section, what we have done is we have transferred the water from one end to another end. So that constitutes a condenser section. And for the adiabatic sections, we have used glass tube so that you can have a flow visualization also. And for heat pipe, we have used copper tube, right? And thermocouples. Thermocouples we have used for 8 thermocouples totally. 4 thermocouples have been used in the evaporator section. Another 4 thermocouples have been used in the condenser sections. And you can see the 2 devices. One is for data logger, another one is a heat applying devices. So in the heat applying devices, you can set the heat, how many wattage you require. So, and this is also I've shown you the laptop where it records the temperature of all the 8 thermocouples. So since I've told you we have used nanofluids, so for that you have to prepare the nanofluid. There are different methods for preparation of nanofluids. One of the method is ultrasonic dispersion of aluminum oxide in the acetone I have shown you. Okay, where in this ultrasonic dispersion we are going to run for about 45 minutes so that completely the nanoparticles mixes with the base fluid. So the base fluid we have used is acetone, right? So these are the specifications of the oscillating heat pipe. So we have used 4 tons and the length of the copper tube in the condenser 60 centimeter, evaporator section 84 centimeter. Inner diameter we have taken 1.7. Okay, this choosing the inner diameter also very important. See, we need to have an alternative slug and plug inside the oscillating heat pipe. For that, the diameter has to be less only. You cannot have more diameter also, so that there will be no movement of the working fluid inside the heat pipe, right? So glass tube diameter also has been shown. Volume of the copper 3.2, volume of the glass is 1.3. So total volume of the heat pipe is 4.625 milliliters. So how to calculate thermal resistance? As I told you, there are 2 important parameters. One is thermal resistance and the coefficient of heat transfer or heat transfer coefficients. So thermal heat transfer will be calculated by measuring the evaporator temperature and the condenser temperature. How the evaporator temperature is measured? As I told you, we have 4 thermocouples in the evaporator section. So that 4 thermocouples, whatever the temperature, we have to make it average. You are going to get the evaporator's temperature, and even 4 thermocouples we have used in the condenser sections. That can also be averaged to get the condenser temperature divided by heat input. So as I told you, you can have 15 watts, 20 watts, 25 watts. So that will give you the thermal resistance. Then heat transfer coefficient again, Q by A times TE minus TC. So area means here the area of the condenser. You have the area means area of the condenser. You know the diameter, so pi dl. Because from the surface, the heat will be transferred. So we have to take the perimeter of the condenser section. So it is given pi times diameter of the heat pipe, then the length of the heat pipe in the condenser section. So you are going to get the heat transfer coefficient. So these are some of the results of thermal resistance of the conventional fluids as well as nanofluids. This actually figure shows you the first figure shows this figure 4.1 shows temperature change of ethanol to the oscillating heat pipe for different fill ratios. I've taken fill ratio from 40% to 80% in steps of 10% fill ratio for different wattage from 15 watts to 40 watts in steps of 5 watts. So if you take particular fill ratio of 40%, as the wattage increases, that temperature change here means the difference between evaporator temperature and the condenser temperature. It keeps on increasing. For a particular fill ratio, the temperature change is going to increase. And as the fill ratio is increased from 40% to 80% in steps of 10% fill ratio, the temperature change is actually decreasing. So as I mentioned earlier in my literature survey, as the fill ratio is increased, the temperature change is also decreasing. So that means you are going to have more heat transfer means. And I have plotted thermal resistance of ethanol in OHP. So here you can see the thermal resistance for a particular fill ratio of 40%. As the wattage is increased, the thermal resistance is actually decreasing. Similarly, for 50%, 60%, okay, and you have minimum thermal resistance for 80% compared to other fill ratios. And this sketch actually shows the temperature change of as well as thermal resistance for methanol. And this figure shows the temperature change and thermal resistance for acetone. The trend is actually same, whether it's acetone, ethanol, or methanol. But out of these three, we have found acetone has got more heat transfer. So we have taken acetone as the base fluid and we have mixed the nanofluids like aluminum oxide as well as zinc oxide as the nanofluids, taking acetone as the base fluid. So this figure actually shows the temperature difference for 1% aluminum oxide nanofluid with acetone. So you can see here, again, the trend is actually same as I told you earlier. For a particular fill ratio, temperature change is going to increase, and if the fill ratio is increased, the temperature change is going to decrease. And thermal resistance actually opposite to the temperature difference. Okay, for a particular fill ratio, the thermal resistance is actually decreasing, and as the fill ratio is increased, the thermal resistance is actually decreasing trend. This is for 1% Al2O3. This is for 2% Al2O3. And this is actually, this figure shows for 3% aluminum oxide as a nanoparticle. So the trend is almost same. Also, we have used zinc oxide as the nanofluid with acetone. And again, this figure actually shows for the acetone plus 1% ZNO nanofluid temperature difference as well as thermal resistance. This is for 2% ZNO, and this figure shows for 3% ZNO. Also, I told you one is thermal resistance, another one is heat transfer coefficient, which are the two important parameters in the heat transfer. So if you take heat transfer coefficient, okay, as the wattage is increased, okay, the heat transfer coefficient is actually increasing. For a particular wattage also, the heat transfer coefficient is increasing. Similarly, for ethanol, methanol, and acetone. And if you see here the values of heat transfer coefficients, we can see that acetone has got the more heat transfer coefficient. So we have chosen acetone as the base fluid. Again, heat transfer coefficient for aceton with 1% Al2O3, 2% Al2O3, and 3% Al2. If you compare these three figures, we have found that heat transfer coefficient for aceton plus 2% Al2O3 is more compared to 1% and 3% Al2O3. So this is a heat transfer coefficient for taking zinc oxide as a nanoparticle. So again, 1%, 2%, 3%. Again, we have seen that compared to 1% and 3%, so 2% ZNO nanoparticle has got a more heat transfer coefficient. So this figure actually shows the minimum and the maximum thermal resistance for different working fluids, that is for conventional fluids as well as nanofluids. So as I told you, aceton plus 2% Al2O3 has got the minimum thermal resistance compared to any other fluids. Again, heat transfer coefficient, you can see the trends. Okay, so for different fluids, aceton plus 2% Al2O3 has got the maximum heat transfer coefficients. And even if you take ZNO, aceton plus ZNO, 2% ZNO has got the maximum heat transfer coefficient. So finally, conclusions. So the heat transfer coefficient thermal resistance for conventional fluids and nanofluids were all evaluated by experimental study for different fill ratio from 40% to 80% fill ratios, and even the E2 input was varied from 15 watts to 40 watts. So as I told you, with the higher fill ratio, you are going to have maximum heat transfer. So the findings indicate addition of nanoparticles to the base fluids has influenced the thermal performance of oscillating heat pipe. Nanofluids exhibited enhanced the heat transfer coefficient as I shown you in the graphs. So moreover, nanoparticle concentration of thermal performance was recorded and higher gradients leading to improved heat transfer performance. So the characterization of OIP using different nano provides valuable insights into the potential application in heat transfer systems. These are my references. Thank you, sir.
Any question from audience? Yeah, I think there are no questions from you. So thank you very much, Prashant, for your informative talk on mechanical engineering background as well. So on behalf of all the officials of DTE and higher education, thank you very much for your session. With this,
Thank you, sir.
AROHAN series 20 will come to an end. Thank you very much for all the participants for joining us. Thank you.